Hey Nerdinas! Today I am back with another video. We are going to be discussing the fundamentals of electronics. As you know, almost everything we use is powered by electricity. So we will be starting our discussion with the fundamentals of electricity itself. What exactly is electricity? Electricity is simply the flow of electrons. An electric charge causes electrons to move across a material. In this diagram, these are the electrons. They circulate in orbits around the nucleus. The speed at which electrons can move determines whether the material is what we call a conductor or an insulator. Conductors are simply materials that give up electrons easily. This means that they have more electrons that can be used as charge. Insulators are materials with electrons that are tightly bound to the nucleus. As we all know, examples of conductors include copper, aluminum, and a variety of different metals. A common insulator is rubber, which we can find coating many of our wires. Magnetism and electricity are actually quite similar. But what exactly makes electrons move from one point to another point? What makes electrons flow? Electrons have a negative charge and are therefore attracted to positive charges, just like magnets, where like charges repel and opposite charges attract. Electricity, therefore, always flows from negative to positive, with the negative electrons being attracted to the positive terminal. So what does that mean about our power sources? Power sources use attraction and repulsion to create a continuous flow of electrons. This means that our power sources are using chemicals, such as a battery, or magnets, such as a generator, to continuously keep the flow of electrons going. Now, let's talk about the specifics. So, current is the way in which we measure the speed at which electrons flow through a wire. Current is measured in amperes and is named after Ampere, who was a French scientist that studied both mathematics and physics. Let's think about current in terms of water flowing through a pipe. In this example, the current would be the speed at which the water is coming out from the pipe. Here it seems to be relatively slow. Next, the next measure we have is voltage. Voltage is the measure of the strength of the electric charge from a power source. In our water example, it is the equivalent of pressure. Here we can see that the water is coming out with a relatively low pressure, meaning that it would have a low voltage. Here, the water is coming out with a high pressure, so this would be a high voltage if we were thinking about it in terms of electrons flowing through a wire. Voltage is measured in volts and is named after the Italian scientist Volta, who was also the inventor of the battery. Next, we have resistance. Resistance is the property by which the flow of electrons through a material is limited. Resistance, therefore, decreases the amount of current that comes through a wire. In our example with the water, the resistance would be the size of the pipe. Obviously, if we have a larger pipe, more water can flow, but if we have a smaller pipe, such as the tap seen here, less water will be able to flow. And these pipes have different amounts of resistance to the amount of water that can flow. Resistance is measured in ohms. Conductors have a low resistivity, meaning that more electrons can flow at one time, while insulators have a higher resistivity, so less electrons can flow at one time. This pipe, therefore, has a lower resistivity, while this one would have a higher resistivity. Resistance depends on three main factors. The first one is the length of the material. Think about having a long pipe. If the pipe is extremely long, it's going to be harder for water to flow through it and come out the other end. Next, you have the cross-sectional area of the material. This means that obviously more water can flow through a wider pipe compared to one that is thinner and smaller. And lastly, you have the composition of the material. Imagine that maybe you had a pipe that was made out of cloth. Obviously the cloth would absorb most of the water, but if you had a pipe that was made out of another material such as a metal, all the water would be able to come out the other end. Voltage, current, and resistance have an interesting relationship. The voltage is equal to the current times the resistance. This essentially means that if electrons are flowing at a greater speed through a wire, there has to be a greater push from the power source and less resistance. Think about this in terms of our water analogy. If the water is flowing with a greater speed through the pipe, there has to be more pressure, which would increase the speed. And similarly, there would also have to be less resistance so the water can continue to flow at a good speed. To take a lot of what we have just learned and relate it to our everyday lives, my room has a 60-watt bulb. A watt is a measure of power, and 1 watt is equal to the current flow of 1 ampere with a voltage of 1 volt. Power is equal to voltage times current. Just a quick side note, most power plugs in the US have 120 volts, but international power plugs around the world have 220 volts. Our electric bills are calculated through kilowatt hours. This means that the number of light bulbs is computed along with the time that each light bulb is used for to come up with a monthly electric bill. This concludes our video about the fundamentals of electricity. From each Nerdina to all Nerdinas. Adios.